The Gulf Stream current could collapse in 2025, that's only in 2 years, plunging Earth into climate chaos. We were actually bewildered, the scientists state. Researchers have predicted the collapse of the AMOC could happen anytime between 2025 and 2095, far sooner than previous predictions, although not all scientists are convinced of this. The vital ocean current system that helps regulate the North Hemisphere's climate could collapse anytime from 2025 and unleash climate chaos, a controversial new study warns. The Atlantic Meridional Overturning Circulation, AMOC, the Gulf Stream as we know it, which includes the Gulf Stream, governs the climate by bringing warm tropical waters north and cold water south. But researchers now say the AMOC may be veering towards total breakdown between 2025 and 2029, causing temperatures to plummet, ocean ecosystems to collapse, and storms to proliferate around the world. However, some scientists have cautioned that the new research comes with some big caveats. The AMOC can exist in two stable states, a stronger, faster one that we rely upon today, and another that is much slower and weaker. Previous estimates predicted that the current would probably switch to its weaker mode sometime in the next century. But human-caused climate change may push the AMOC to a critical tipping point sooner rather than later. Researchers predicted in a new study published Tuesday, July 25th in the journal Nature Communications. The expected tipping point, given that we continue business as usual with greenhouse gas emissions, is much earlier than we expected, co-author Susan Dilveston, professor of statistics and stochastic models in biology at University of Copenhagen, told Life Science. It was not a result where we said, oh yeah, there you have it. We are actually bewildered, she said. The AMOC is a global conveyor belt. Atlantic Ocean currents work like an endless global conveyor belt moving oxygen, nutrients, carbon, and heat around the globe. Warmer southerly waters, which are saltier and denser, flow north to cool and sink below waters at higher latitudes, releasing heat into the atmosphere. And then once it has sunk beneath the ocean, the water slowly drifts southward, heats up again, and the cycle repeats. But climate change is slowing this flow. Fresh water from melting ice sheets has made the water less dense and salty, and recent studies have shown that the current is at its weakest in more than 1,000 years. The region near Greenland, where the southerly waters sink, known as the Northern Atlantic Subpolar Region, the subpolar gyre, borders a patch that is hitting record low temperatures, while the surrounding seas climb to all-time highs, forming an ever-expanding blob of cold water. The last time the AMOC switched modes during the most recent ice age, the climate near Greenland increased by 18 to 27 degrees Fahrenheit, that's 10 to 15 degrees Celsius, within a decade. If it were to turn off, the temperatures in Europe and North America could drop by as much as 9 degrees Fahrenheit, that's 5 degrees Celsius, in the same amount of time. Direct data on the AMOC strength has only begun recording since 2004, so to analyze changes in the current over longer time scales, the researchers turned to surface temperature readings of the subpolar gyre between the years 1870 and 2020, a system which they argue provides a fingerprint for the strength of AMOC circulation. By feeding this information into a statistical model, the researchers gauged the diminished strength and resilience of the ocean current by its growing year-on-year fluctuations. The model's results alarmed the researchers, yet they say that checking them only reinforces their findings. The window for the system's collapse could begin as early as 2025, and it grows more likely as the 21st century continues, they said. Peter Delvinson, professor of physics and climate science at Niels Bohr Institute, Copenhagen, said, I don't consider myself very alarmist. In some sense, it's not fruitful. So my result annoys me in some sense, because the window for possible collapse, is so close and so significant that we have to take immediate action now, he says. Controversy over the predicted collapse. Oceanographers and climate experts have said that while the study provides a worrying warning, it comes with some big uncertainties. If the statistics are robust and are correct and relevant way to describe how the actual modern AMOC behaves, and the changes relate solely to the changes in the AMOC, then this is a very concerning result, said David Thornley, professor of ocean and climate science at University College London. He said, but there are some really big unknowns and assumptions that need investigation before we have confidence in this result. Other climate scientists have gone so far as to pour cold water on the findings, suggesting it is wholly unclear that observed surface temperatures evolution of AMOC can be linked to the strength of its circulation. While the mathematics seem expertly done, the physical foundation is extremely shaky. It rests on the assumption that the collapse shown by simplified models correctly describes reality, but we simply do not know, and there's no serious discussion of these simplified models' shortcomings. Joachim Marotz, professor of climate science and director of the Max Planck Institute for Meteorology in Hamburg, said, hence, while the paper might be a valid what-if exercise in time series analysis in a specialized journal, it falls way short of its self-proclaimed goal of estimating the evolution of the circulation solely from observations. The researchers behind the new study say their next steps will be to update their model with data from the last 3 years, which should narrow the window for predicted collapse. And this is by Ben Turner on Live Science. Please leave your comments and thank you for your support. This is a simplified animation of the global AMOC conveyor belt with surface currents shown in red and deep sea currents in blue. So the surface temperatures are in red, deep sea is in blue. This is from NASA Goddard Space Flight Center Scientific Visualization Studio. Deep water formation in the north, you can see the surface temperatures and go deeper. Deep water formation right under Greenland. And you can see how the Gulf Stream, for example, comes up from Florida up to, the British Isles, as you can see, and then comes down lower. And this whole thing circulates around the world. Deep currents, surface currents, deep water formation there in Antarctica, deep water formation. Okay, so I'll leave links below for you for this on Live Science. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.